This presentation is going to examine the hypergeometric model for probabilities. Here's a standard sort of question. There are 7 red, 5 blue, and 6 green marbles in a bag. If 4 marbles are selected at random, what is the probability of selecting exactly 2 red and exactly 2 blue? So we have 7 red, but we want 2. How many ways can we select 2 from 7? That, of course, is going to be 7 choose 2. We have 5 blue, we need to select 2. How many ways can we select 2 from 5? That, of course, is going to be 5 choose 2. We don't want any greens at all, so how many ways can we select 0 elements from 6? As we know, that's just going to be 1. So those are the 3 numbers that we're working off of. But then how many numbers do we have all together? How many marbles are in the bag? 7 plus 5 plus 6, 18 marbles in the bag, and we're selecting 4. So that's going to be important for us with our denominator. So putting all this together, then what do we have? 2 reds, 7 reds I want 2, 5 blues I want 2, 6 greens I want 0, divided by 18 total marbles I want 4. You'll notice 7 plus 5 plus 6 is 18, 2 plus 2 plus 0 is 4. Now to do this, let's go to Excel to see what those numbers are going to look like. So these are the numbers we need. 7 choose 2. We're going to type equals combin 7 comma 2. We get that number. For 5 choose 2, we're going to type equals combin parentheses 5 comma 2. And for 6 choose 0, we're going to type equals combin 6 choose 0. That, of course, should be 1. And it is. And our denominator is going to be 18 choose 4. So we'll type equals combin 18 comma 4. And then for our number, we're going to want to do the multiplication of these 3. This one times this one times this one divided by this one. And we get our number of 0686. So indeed, the probability of getting 2 red and 2 blue marbles in this situation will be 0.0686. Okay, our next question we have again, 7 red, 5 blue, and 6 green marbles in a bag. If 4 marbles are selected, what's the probability of getting 1 red, 1 blue, and 2 green? Well, we have 7 red marbles, we want 1. 5 blue marbles, we want 1. 6 green marbles, we want 2. And 18 marbles total, we want 4. Again, notice 7 plus 5 plus 6 is 18. 1 plus 1 plus 2 is 4. So let's go take a look at Excel and see if we can find these numbers. So here are the numbers we need. We need 7 choose 1 equals combin 7 comma 1. No surprise, that's 7. Next one equals combin 5 choose 1. And we know what that'll be. That'll be 5. But we'll let Excel do it. And then we need equals combin 6 comma 2. And we've already done 18 choose 4, but we'll do it again. Equals combin 18 comma 4. You see we have those numbers. Now to get our probability, we're going to say equal this first number times the second number times the third number divided by the denominator, and we get 0.1716 approximately. So indeed, the probability of 1 red, 1 blue, and 2 green is about 0.1716. Our next example, we have 10 men and 12 women in an office. 6 people must be selected to attend a meeting with the CEO. If people are selected randomly, what is the probability that 2 men and 4 women will be selected? So there are 10 men, we want 2. 12 women, we want 4. So how will that be represented? 10 choose 2 for the men, and 12 choose 4 for the women. How many people total in the office? 10 plus 12 is 22. 2 plus 4 is 6. So our denominator is going to be 22 choose 6. Now putting these things together, 10 men we want 2, 12 women we want 4, 22 people total, we want 6, and we will again go to Excel to find our values. So here are the numbers we need for this example. For 10 choose 2, we type equals combin 10, comma 2. For 12 choose 4 equals combin 12, comma 4. And for 22 choose 6, we're going to say equals combin 22, comma 6. And putting these things together, what are we going to need? Equals this first number times the second number divided by the number in the denominator, and we get 0.2985. So the probability of having 2 men and 4 women selected will indeed be about 0.2985. Okay, here's a way for us to check this on Minitab. We are going to generate 100,000 numbers, and here's how this works. 22 people total, 10 of those people are men, and we are selecting 6. So the first number is the total in the group, the last number is how many you're selecting, and this number has to describe one of your 2 categories. So we're going to be counting the number of men. So this is going to generate 100,000 different groupings of 6. Looking at the table, 0 men happened 1,264 times. 1 man happened 10,581 times. But the interesting one is here. 2 men, which would mean 2 men and 4 women, since 6 are being chosen, happened 29,902 times. And this gives us a chance to go ahead and get an approximate probability. Our relative frequency of success for 2 men, which of course implies also 4 women, 29,902 divided by 100,000, or 0.29902, which is very close to our original theoretical probability. Okay, our next question is, 7 cards are randomly selected from a deck. Find the probability that at least 1 card is a faced card. Well, this at least 1 is, of course, interesting. When you see at least 1, we want to think complement. So the probability of at least 1 face card will be 1 minus the probability of 0 face cards. So we want to find out the probability of 0 face cards. So for 0 face cards, what are we going to have? 12 face cards, we want 0. 40 other cards, 40 non-face cards, and we want 7, since we're choosing 7 numbers from this, 7 cards from this deck, divided by 52 cards total. Notice 12 plus 40 is 52. Choose 7, 0 plus 7 is 7. So again, let's go to Excel to work on these numbers. So in our first instance, we have 12 choose 0. Of course, 12 face cards, we don't want any. So equals combin 12, comma 0, which is just 1. 40 choose 7 equals combin 40, comma 7, and we get a very large number. 52 choose 7 will be even larger, equals combin 52, comma 7. We want to multiply the 2 numbers on top and divide by the number in the denominator. So equals this number times this number divided by this number, and our result is 0.139355. So what is that corresponding to? The 139355 or 1394 is the probability of 0 face cards. But remember what the question asked. It's asking us to find the probability that at least 1 card is a face card. We want at least 1 face card, so we're going to need to use our complement rule. Quickly checking it on Minitab, 100,000 numbers, 52 cards, 12 face cards, we're selecting 7. Adding up all of those numbers from 34892, 32131, all the way down to 1, at least 1 face card, we get 86096. So we'll recall that our theoretical solution for 0 face cards was 0.1394. So what will at least 1 face card be theoretically? At least 1 face card, 1 minus the probability of 0 face cards, 1 minus 0.1394, which is 0.8606, which is very close to Minitab's answer, also around 86%.